Everyone. My name is Pauline. I am a privacy engineer in Android. I have been at Google for over 7 years, working on privacy throughout the entire time. In this session, you will hear about how some of the privacy features on Android were engineered and came to its realization. I will also provide an overview of all of the new privacy features we introduced in Android 12. So before diving into this year's update, I want to take a moment to discuss our mission and strategy. Our mission is to protect the billions of Android devices out there, and regardless of whether it's a high-end device or a low-end device, our goal is to provide the same level of privacy and security. So firstly, the Android privacy and security model relies on a defense in-depth approach. Throughout Android, you will find multiple independent layers of privacy and security architecture and mechanisms designed to work together seamlessly and effectively. And secondly, transparency is key to our philosophy. Android is open source, and we publish a quarterly ecosystem transparency report and blog frequently about upcoming features and capabilities. And finally, Google has a tremendous team of security and privacy experts, and the Android team partners closely with many of these experts when it comes to things like anti-phishing, account security, privacy, and many other initiatives. So the functionality provided by mobile devices has significantly evolved over the past 2 decades and continues to rapidly advance. When we first introduced mobile devices were basically cellular phones designed to make telephone calls. Once modern mobile OSs were introduced over a decade later, the threat landscape drastically changed as users began trusting these devices with large quantities of sensitive personal information. In Android, we have teams working on various sections of the attack surface, system, apps, phishing, and end user. And today, I will be focusing on how we harden the system features. So if there is one key message that I want you to take away from this talk, it's the following, right? Privacy engineering in Android is very much a collaborative effort. As you will hear in a few minutes, we work with external researchers, developers who identify vulnerabilities. We collaborate internally with system engineers and product teams to come up with solutions. And we need to align all of our solution with release schedules, business needs, and many other constraints. And as you can imagine, it is not easy to get all these people across the organization to move harmoniously together. The Android ecosystem moves very slowly, and sometimes we need to break the problem down into smaller pieces and then solve them in stages. So my next example of the feature is one such feature where we collaborated with academics, right? And this feature is essentially on-device fingerprinting. And the result of this work was done across 3 years and 2 Android releases with the collaboration of researchers from Cambridge University in the UK. Right. So as many of you know, fingerprinting is the use of unique or probabilistically unique combinations of one or more device, network, or app attributes to identify a device, app, browser, or user across distinct transactions, where no persistent unique identifier is explicitly provided by the user's device, app, or browser. But then, we're able to figure out these unique identifiers. And in current smartphones, they include a set of motion sensors, accelerometer, gyroscope, and magnetometer. And data from these sensors can be accessed by developers via the Android APIs that is available, and they were previously not guarded by any permissions. And But however, these sensors that are on the mobile device suffer from deterministic errors due to manufacturing imperfections. And these include scaling error, non-orthogonality error, and biases. So some vendors use per device factory calibration to alleviate these deterministic errors. The researchers that we worked with proposed a novel attack which infers these calibration parameters from the sensor output alone. So the calibration attack that they basically showed us takes less than 1 second, requires no permission or interaction from a user, and can be launched from both mobile and a web app. And this will generate a globally unique and consistent immutable identifier. So there are 3 different types of calibration matrices that can be calculated. During the factory calibration, after the manufacturers have these matrices, they would bake this data into the non-volatile memory of the device, and this stays permanently. Motion sensors first convert the analog measurements to a digital value through analog to digital converters. Then the calibration matrices would be applied to this ADC output to generate the sensor readings based on the formula that I've shown here. So the objective of the attack that was presented is rather straightforward. They just want to recover the value of the gain matrix G. So here's how the attack works. First, they got some raw data samples that was collected from the sensors. Then, by subtracting the consecutive sensor measurements, the bias can be removed. And then eventually we get the formula, which is shown below here, which is delta O equals to gain matrix G multiplied by matrix delta A. And at this point, only the value of delta O is known. Normally, it will be difficult to infer the value of the gain matrix because we don't know the value of delta A. But then there are some known properties that can be exploited here. The output of the ADC value can only be an integer, which means that the matrix delta A only has int values. And then secondly, we also know that the gain matrix G is close to its nominal value. A nominal value here is essentially the value that the sensor is designed to operate at. And this value is often documented in the sensor data sheet. And all of these properties essentially allow the researchers to infer the value of delta A and further estimate the value of the gain matrix G. So here I just want to show you a plot of the accelerometer. So when they reported this issue and they published the paper, we essentially reproduced it internally. And here's a plot of the accelerometer data from a Pixel 2 device. When we take the difference between the sensor values, you see a strong fluctuation in the values, which shows that they were factory calibrated. And based on this plot, we can see that there is a clear quantization, as you can see the lines of the sensor output. And this is because of the ADC values are integers. And based on this quantization, we can know the value of delta A for each data point by simply observing which quantiles the point lies in. And therefore, they estimated the scale of each axis from the accelerometer outputs and then used them as the fingerprint ID. And if the sensor outputs, and they did this on Pixel devices and iPhones. And if the sensor values were not calibrated as shown in this plot here, which is a Samsung Galaxy 8, then we would see that all of the values will be the same, as you can see here. So what did we do? So we worked internally with the sensor framework team, and we reproduced the issue. And the attack essentially computes the device and how much entropy did this ID have. So we estimated that it had 57 bits of entropy. And this was tested on a Pixel 4 and Pixel 4 XL devices. And there was like a 97% chance that 100 million devices have such a unique ID. And as a mitigation, what we did is we requantized the gain matrix. So essentially, we rounded the sensor output back to the multiples of the nominal gain. And we applied this fix to all of Android last year, including Android 11, and we tested this on various Pixel devices. So here, I just want to, again, highlight how this was essentially an issue that was brought to our attention at a conference, and then we worked together with the researchers. So when we had the fix in place, we essentially reached out to the researchers and then asked them to validate that they were able to not be able to reproduce the attack. So it was a very collaborative effort. So as a follow-up to what I just talked about in terms of device fingerprinting work, we further did some improvements to the Android sensor framework to prevent misuse of the sensor data and protect users' privacy. There are several side channels that can be used to derive sensitive information from these sensors and without any user control or awareness, right? And there is a steady stream of researchers who are reporting unexpected ways to collect these sensor data and then infer sensitive data using these sensors. For example, the stream of papers that came out was like accelerometer, could be used to reconstruct part of speech and used as a microphone, or accelerometer can be used as a keystroke logger, and so on and so forth. So in Android 12, what we did is that if your app is targeting Android 12, the system places a limit on the sampling rate of these sensors. And the sensors impacted here are accelerometer, gyroscope, and geomagnetic field sensors. And the refresh rate here really depends on how you access the sensor data. So if you use the register listener method to monitor the events, then the sampling rate is limited to 200 hertz. And if you're using the sensor direct channel, then the sampling rate is limited to about 50 hertz, which when you use the rate normal ENA. And if your app needs to gather these sensor data at a higher fidelity, then we ask that you declare a new normal permission, which we call high sampling rate sensors. And if your app tries to gather this data without this permission, then there will be a security exception which will be thrown. So again, this was a follow-up from the device fingerprinting work. And this is right now present in Android 12. Right. So now I would like to, highlight some of the new privacy features in Android 12, specifically those which I was personally involved in, starting with the mic and camera toggle. So as you may have seen, there is like no shortage of press articles about smartphones either listening to you or watching everything you do. This showed that the users don't always trust their devices, and this mistrust has led to industries offering users physical phone and laptop camera blockers and apps that promise to make phones more private, right? You have seen people placing stickers on their camera on the mobile phone or plugging audio blockers into their phone. So we realized that users are generally worried about mic and camera. And a recent study on all of the Android permissions that we did further reinforced that the user's sense of discomfort with mic and camera. So on Android previously, we have limited the background access of mic and camera, with some exceptions, of course. But however, this was not enough to build trust with users. Users don't always understand the concept of background versus foreground, and all it takes is an isolated event to lose user trust. So in Android 12, we wanted to provide Pixel users a way to quickly disable their mic and camera. We want to make it easier for users to disable mic and camera with a global toggle similar to the location toggle, which was already present. And the main goal of this was that the toggle should be like discoverable and placed where users can control their privacy features. And this is now available in Android 12. Another privacy feature that I'm very excited about is the 2G toggle, which is a Pixel first feature. And this again was, basically not really a collaborative effort, but this was reported to us continuously. And there were several requests from developers, researchers, EFF to allow users to disable or turn off 2G on their phone. And as many of you know, 2G is known for its security vulnerabilities. For instance, if encryption is used, it can be broken in real time and attackers can intercept the communication. And then site simulators can send authentic looking SMSs to do a bunch of phishing for PII, send spam, so on and so forth, right? And then also in some parts of the world or some attackers can also downgrade a phone which is on 3G, 4G, or 5G to a 2G connection to tap their communications. So to prevent malicious 2G downgrades, in Android 12, we introduce a 2G toggle in settings that will allow users to completely disable 2G cellular connections. So this requires that the phone targets or the hardware targets a radio 1.6 hardware layer implementation. And hence, this is why this is a Pixel first feature. So the 2G toggle is enabled by default, but carriers can disable the feature at runtime through the carrier config flag. And we've also have CDDs in place to ensure that manufacturers, must ensure that all of the networks that are available during emergency call. And as a follow-up of this work, there will be more work done in the next release as well, hopefully. So there was a bunch of privacy features that we launched in Android 12, and I'm just going to give you a few of the big ones, which was key and took a lot of effort, and we're happy that we managed to get it out of the door. So the first one is privacy dashboard. Users often tell us that they want to understand what data apps use. Right. With the new privacy dashboard, users will have a simple and clear timeline view of the last 24-hour access to location, microphone, and camera. You can also share more context about your app's data usage with a new permission intent API in Android 12. The next one is on location. And, location has been a very sensitive information and highly debated. So over the last 2 releases, we've made location permission much more fine-grained than what it used to be. First, we separated the background and foreground access. Then we added an only this time option to further restrict access to background location. We are seeing users respond very positively to these controls and are choosing them more often. When we give the option, users select to share less through foreground location access about 80% of the time. So we took this feature further in Android 12, where we now give users more control over the granularity of their location data. So users will have a clear choice regarding how precise they want to provide the location data to the app by either selecting approximate or precise. Yeah, so the next one here is app hibernation. And this feature is essentially intended to help users' privacy and improve usability of devices by reclaiming storage space and revoking permissions from unused app. So you probably have seen that we revoke permissions from unused app. So and now this is basically we're hibernating the apps. So to achieve this, what happens is apps have been unused for over 90 days will be marked as hibernating, and the system will force stop them, and it will revoke all of its runtime permission and clear its cache. Right? So this way we can actually reclaim some of the memory, storage, and other temporary resources that was used by this app. So another new exciting area in Android 12 is our Android private compute core, right? This is very exciting. This is essentially isolates certain machine learning based features on device so that the data is not shared with other apps or services. And this is the first privacy sandbox of its kind in a mobile operating system. Essentially, any information that is processed in the private compute core will require a user's explicit permission before it can be shared with Google or any other app or service. And like the rest of Android, the protections in private compute core are open source, and it's fully inspectable and verifiable by the privacy and security community. So you will see that tools like live caption, smart reply, process through here to ensure your conversations stay private. And this innovation will also enable a new wave of machine learning based innovations to be built in Android OSs, such as anti-phishing tools that don't compromise user privacy, for example. Private Compute Core is fostering investment in a lot of exciting new features, many of which you can hopefully see in the Pixel first launch. Overall, we launched over 50 plus privacy and security features in Android. Android 12 is probably one of our ambitious privacy release to date. And you can read all about it in the developer.android.com page. So I think I'm almost at the end of my presentation. I hope you have learned a little bit about how privacy engineering work happens in Android. And as I said again, we work very closely with developers, with external researchers, and a bunch of other folks to build all of these new privacy features. And sometimes we don't get to it like in the next release, but then we try to aim to get it out when we think that it really respects users' privacy. And if you are interested in joining us, we are hiring. So you can see all of the links posted here. And with that, thank you very much for your attention.